So what is a type conversion? So mostly people will ask you. So this is a process converting one type of values to another type of is called type conversion. So we have a int data type, correct? So values will be like an integer. So you want to convert in a, like, suppose short type of value, or you want to convert in the long type value, or suppose you want to convert double, or you want to convert in the float, that is int value. So this kind of the conversion is called type conversion. Okay. So not only this, we have another things like class A. Okay, I want to convert in a class B. So that we have to check these are possible or not. How we can do type conversion class A to class B or class B to class A. Okay, so this will be discussed on these classes. Okay, so the process converting one type to a value to another type of is called type conversion. Okay, so type of conversion, how many types of the conversion we have? So there is a winding, okay, there's another narrowing, okay, and then in winding we have a primitive winding and reference. So primitive means this, all the primitive types we already gone through that, correct? The first one integer, short, long, correct? So reference winding means what are the classes we have, like class A, class B, those are reference. Okay, then narrowing, if you go, this is primitive narrowing. We'll talk about this one by, okay, what do you mean by widening, what do you mean by narrowing, okay? And then we have a reference. Okay, so just see this diagram, this is a very important diagram. Okay, so we have a double, we have a float and long and int and short and byte. Okay, double, float, double size are bigger than float, correct? Float and long has a bigger size than int. Do you remember this one, range we discussed? And short has a bigger than byte, int has a bigger than, yes. So yes, so see, this one is going to down, correct? This winding, suppose you are trying to type the values, okay, type conversion, double to float, that is called winding. If you want to cast long value to int, okay, getting my point? And this is called narrowing. Okay, okay, so let's talk about winding data types, conversion, and narrowing. Okay, so first we'll go through this winding. Let's see. So that is called implicit automatic winding type conversion. So why I'm telling the implicit and automatic? That's another part. Implicit means no need to do anything. Automatic, compiler will done this job. Okay, suppose I have a int value. Okay, I want to cast into sort. Okay, so what happened? I can do, correct? I can cast this one. I have a int. There is int is a bigger size. Bigger size means int. Suppose I have a 4,000. Okay, and I want to cast into double or long. You can say long has a more than that, correct? So easily can take. Did you understand? Because long can have a more than integer. So let's see. So converting broader. See that he told, correct? Broader data type is called winding. So you have a smallest one, that is a not a smallest. If you compare to long, that is the small. So you now you're going to convert integer to long. Okay, that is done by automatically compiler. See, int x 4 byte it will take, correct. Long, I'm directly assigning to x. Okay, so because of the long is a 8 byte, you can take this 4 byte of data, correct. So no need to do anything. The compiler be done by, this is done by the compiler itself. So this is called automatic or implicit, you can say. So yeah, so what do you mean by this? We are assigning our values to broader data type. Narrowing, what I know. So next, if you see explicitly and narrowing data types conversion. So I told you you're going to small broader to smaller range data types value. So yes. So performing the convention from the highest range data type variables to lowest data type range. Okay, and that moment, yes, that moment it cannot do that is not done by the compiler automatically. That's explicitly so we I'm coming on that only. I'll stop it. So the cast operator is a data type placed parenthesis after that equal sign. Remember last time what we did? We defined int x equal to 10. Then long L equal to x directly. But here that's not possible. We have to do one cast operator here. So how it will happen? Let's see. This is a L, 8 byte, okay? This is the highest range in integer values. Now I want to assign into int, okay, like this I'm doing. So there is it not possible, okay. The possible loss of the precision some means some data will be lost, okay, that we'll discuss later. So how to do this? This is not possible. How we can do this? So doing this one we have to put like this inty, then if you see the parenthesis intl, this is called casting. Okay, so that only you're talking, correct. So we are giving as a explicitly typecast this L value to Y. Okay. Which one? No, no, it's not a function. Int another data type where you want to where do you want to cast. Suppose I have a sort. Okay, I want to sort this one, so I have to pass sort. So compiler can understand this value is going to be become a the long value became a int if I am sorting this one. Okay. So this asking by using the cast option, we can convincing that compiler that values in the source type variables within the range of the cast operator. So I'll tell you this. That's I wanted to talk to you. Suppose um, we have one values. Okay. Uh, int. Okay. I have put int 256. Suppose yeah 256. Okay. And then I have a byte. Okay. And I want to assign that byte. This 256 values range to byte. But you know what is a bytes range? Byte range is a 120 say 128 to minus 128 to 127. Remember byte. So but I'm assigning to 256 values to byte. That not possible, correct? If you do typecasting also, how is it possible? The range is going to out. How is it possible? Not possible, correct? At that moment, what will come? Possible of data loss. Okay, but last time what I did, I take a long L. Okay, I assign 20. Then I'm assigning the 20 to integer. That is possible. 20 can take this one. int can take 20, correct? This is range of this int. So some moment whatever I have a bigger data that I want to assign my uh, lowest range data type. So sometime it will not happen, means some value will going to loss. Possible loss of precisions. I told you. See this one. See this 20, correct? Integer can take 20, but suppose we have a 20 lakhs. Integer cannot take. That moment what happened? Possible loss of the precisions. It can happen. Okay. I'll tell you how to calculate this also. Okay. So so if you're doing this cast operator, that means you're telling to compiler that values are okay for you. This is a fine. You can cover this range of data for your source data type. You understand that point? Okay. So we are allowing to regime to reduce the source value to cast operator type if it is a range is greater than the cast. Okay, that is also possible. So that I wanted to talk to you. So that question we discuss how this. What will happen? Source variable has a greater value than destination type range. I told you, correct? Means int have a 254 and you want to assign this a byte. Okay, so what will happen? So assignment by the reducing this value casts a range of use the two complements. So I'll tell you how it will work. And so what happened? They will calculate this on this logic, two complements, and then what are the data will come, what are the values will come from this logic. It will store to your destination variables. Like I have a one int, okay, int 254. Then I'm going to typecast this int to byte. There is one concept we have two complements. So that what are that data will come from this by these two complements. So the data will store in the byte. So there is chances we lost some data. We'll see how. See, this is what I'm trying to say. Uh, what we trying with this forcing to JVM to allow this typecast. JVM will do no problem, but there is a chances possible loss of precisions. Some data we are going to lose. See, if you see this on 254 and 90, okay, byte assign x. Okay, the result will what happen? Result will be -2. That means we lost all data. See, if you print this one byte to byte b in a SOP, you will get data a result like a -2. How? See how much data we lost. So I'll tell you how this calculate, how it became at -2. Okay. So this will happen. This is called two's complement. So this is happening to all computers, any type of the computers or any type of the operating system. This calculation will happen. If you run the Mac, if you run on a Linux, anywhere you'll run this concept, you will run this way. So mean range plus result minus max range. Okay, and then -1. This is a concept to use this two complements. See, we know what is the mean range of that byte. 1 minus 128, correct? The result we have, the result means what variable we have assigned to x. So that was a 254. Then our maximum range of byte, that is a 127, then -1. This is a formula. Then I just -1 and 128. You can easily understand this. My 254 minus 128 is become a 126. Okay, then if you see this 128 plus and this one, it will come -2. This is the result that will assign it to your byte after type conversion. So this is how much data we lost. You can see that we trying to assign 254, but we are getting -2. Okay, so it will happen in the runtime. Sorry, it will happen in this one will runtime. But suppose you are assigning to byte to int. Sorry, int to byte. The compiler will not do anything. Okay, because we only put the typecasting. Correct? We are okay with that. So we have to take care of this situation. If you are assigned to higher values, we cannot do that. Okay, and that one we should change our data type. So, okay. So rules in the primitive data type conversion. There are some rules. Okay. So do you have any question? Okay. So the first source to destination data type must be compatible. Okay. Like uh, I have a both are numerical. Okay. Like integer is numerical, float is numerical. Correct. But boolean is not numerical. Correct. There's a true false built in. Float is also numerical, but it's a decimal point. We but both are numerical. Correct. Okay, so that should be the source should be compatible with the destination. You can say source to destination data type should be or must be compatible, otherwise it will throw the compile time error. Okay, this is it. Okay, see example, int is a numerical, float is a numerical, we can assign directly, no problem. Why this is no problem? Because uh, int is a 4 byte and float is a 8 byte. Correct. So there is no problem. We can assign it. But okay. But if you are trying to assign it like this, boolean, so float to boolean, we will get this exception, the compile time error, incompatible type found, float. Okay, float required boolean. You cannot assign this float to boolean. You need a boolean only. So this exception will get in the compile time. Okay. So next one. Uh, so less than or equal. We talk about this, correct? This possible of loss precision that will come. Should be take care of this. Whatever the data you're assigning, it should be in the equal to or less than. If you're going more than that values is more than your destination, then we'll get a problem. Possible loss of the precisions. Range, I'm talking range. What are the values you have? It should be your range. Suppose I talk about this, correct? So your byte is a 127 range maximum, okay, but you are assigning 254. Your source is a 254, your destination is 127. At that moment we'll get a possible loss of the precision, what we have seen in the last example. Okay. See. Okay. uh, this is not a completely good example. We can achieve this one. Suppose what I put 10, correct, at the top. So if I do typecasting here, we can achieve this one, correct? Did you see this? If you put typecasting, because 10 is under the integer range. But if you're not doing any typecasting here, you will get exception like this. Okay, float required to int. Okay, if you do typecast, you can do this. If you're putting more 10 lakhs, 20 lakhs, so that time you'll get a, if after typecasting also you'll get a issue. Okay, you understand this point, correct? So same only what I told you. This is just surprise. Typecasting must be compatible and source type, else it will give a compile time error. Okay. The second one should be compatible destination type. What we have discussed just now. Second rules. Okay. And this one range must be equal to or greater, less than your destination type. This is fine. I think we discussed this. Okay. So reference type, we talk about this primitive type conversion, correct? Now we talking the reference type. I told you reference means we have object, correct? So converting one objects to from another reference type of objects, that is called reference type conversion. Okay, so should be compatible. All are same only. Means what we have discussed in primitive type, similar kind of, but there is some different concept. Primitive what we discuss winding and narrowing, correct? There is a something called easier relationship. So we have a 2 3 classes, okay? We have a 2 3 classes with, now we have, suppose we have a class A, class B, class C, class D. We want to type conversions all. So we have to check these classes have a easier relationship If they have a easy relationship, only we can do reference type conversion. Remember this point, okay? If we have a easy relationship, then only we can do reference type conversion. Suppose we sometimes will do forcefully, okay, like what we have done that through cast operator. Same thing we can do in a reference type also, but in runtime we'll get some issue. We're getting runtime issue in the primitive types because the range is more than your destination. Okay, here also some we have some issue. Let's see, we go going through this. Okay, so we'll talk about easy relationship. See, easy relationship means that class. Do you know this? We have a inheritance concept. One, okay, easy, correct. One object is, yeah. So that is inheritance concept is completely based on your easy relationship. Okay. So inheritance, how we can implement? We can get this inheritance by the extending the class or implementing the class interface. Okay, extend or implement that we will discuss more on the time the OOPS concept, but for now, okay. Just see this. We have a parent class. This is for example only. What is the inheritance kind of this? We have a parent class. There is two methods. So display. Okay. Then we have a child class. Child class extend the parent class. Okay. We have same method. We override this show method and create a new method print. This is called inheritance. Okay. They have a easy relationship between, okay, child and parent. Okay. So let's example on this. We have an object. Okay. I want to just explain this easy relationship. That's important. Okay. We have an object. Then we have A class, B class, and C class. Okay. Then we have a D class. Okay. D class is a extend by, it's extended to object. Okay. By default is a object is a superclass for every classes. Correct. So see, object A class is a uh, superclass of B, B class is superclass of C. You can see this, correct? See, let's see who are a easy relationship. See, object class is a superclass of all user defined and predefined classes that you know. Correct? This is very important. Object class is superclass for all user defined and predefined classes. Okay. Then class A has a is a subclass of objects. Means you can see this between this object class and the A class. We have a is a with object. Did you see this one? The second point. Okay. Then B class has a is a subclass of A. That means we can assign, see, you getting my point, B to A. And then we have a C. C has a is a subclass of A and B both. Okay. B has a in object. A have a only for object, not for B. B not for C. Remember this one, okay? And D is a completely different. They don't have a sub extended by the A and B and C. See, D is a subclass of objects and siblings of A and B and C. Nothing, okay? There's no easy relationship with A and B and C. Okay? The last point is very important, okay? So I hope we'll implement this way. Let's see, fine. See, this class A, class B, class C. What we have put in the diagram, I'm putting in the code now. Okay. Now we have a D. This is a class I created by Java program. Okay. And then I'm creating type conversion class. This one, see, class. Okay. Then I'm going to type. I told you this is all about the type conversion. Okay. See, main method. I created an object class. Okay. Okay. Now I'm trying to convert. I told you this is a relationship, correct? A class is an easier relationship with the object. Now what I did, I created an object A, and now I'm trying to assign object class object. Okay, object. If you see this, these all are possible. Okay, because why is all possible? See, every basis we have a object class is a relationship, correct? Object. See, all classes. Object. See, object. So everyone has a relationship with the object. Did you see this? Super class. So we can assign this object class object data to any other type of the instance. B, these all are work fine because for every class, object class is super class, correct? Means they have a AJ relationship. Okay. Now I'm going to create a class. Do you remember? A has a relationship only for A, for B and C. For D it doesn't have, correct? D is a siblings, not easy relationship with the A. Okay, see. You understand this point again and go. See, if you see, we have A, this is same class. B, we have a relationship with the B, correct? For C also we have. You can see for both, correct? So we can do this, correct? But we cannot do on D. D is a compile time error will get. We cannot do this. Okay. Now I create an object for B. See, I cannot do this. Okay. So I can do that one. C can object can assign to B3. You understand this point? Okay. See this also because this all are will get a compiler error. Okay. And D we can yeah. And that moment D will get a, all the compiler error because D is a siblings. It's not a your subclass or superclass. Okay. Now how we can achieve that one? I told you, correct? We have a automatic concept, so automatically we can do directly uh, upcasting. Okay, so we have a parent class. This is a kind of uh, relationship we have parent class and then child class we're trying to assign. Okay, okay. So uh, did you understand that part? Or should I explain this? So this we have a upcasting, correct? So we have a child class. We're trying to typecast to the parent class. We can do that class A to class B. What we have seen this, correct? So if you're going to downcast, uh, if the parent class object is referred by the child class, okay, then it will be called as a downcasting. Means going to downcast. You need to that where we're getting a compile time error that moment. Okay. Now we want to typecast. Suppose you're putting this typecasting, this parenthesis, okay, what I have put in the board, it will happen in the runtime, compile time. Okay, you can do the compilation time, but we'll get an exception in the runtime. That is exception will come class cast exception. This will come in the runtime. Remember, we did we put it in the compile. This will put correct. We define it in. We saying to do this. Compiler will do okay. They have written this. They are okay with this. Okay, fine. Compiler will compile. There is no compilation error. Okay, but runtime it will get D. Now I trying to D to which class A. Both are they don't have AG relationship, correct? And we don't have this because they did not extend it. How we can assign it to them? Both objects are different. A object is completely different. B is completely different. How we can assign? But if you put this typecasting, compiler will be ignore this one. Okay, they are okay. This programmer is okay with this. It will do. But at the runtime, we're doing the conversion. Class D to class A. It will get exception. Okay, that is a runtime. That is called class cast exception. Okay. So how this one, what I'm trying to say. Okay. See the example. Compiler will check. Compiler, what will check compiler? See. Okay. Check the objects easy. Huh? Sorry. Yeah. Okay. So compiler will check and then will do typecasting. The they'll check first object type easy relationship. No. So then check is it object types? Yes. Correct. So that's why he's getting to this object types. So how we did this. Okay. So it will go through them. Yeah, understand the point, correct? Because these all are similar to our primitive types. So most of time you remember this, you will get this all the class cast exception at the runtime in a production anywhere. So we should know this how we got this class type exception. And then now the problem we're getting the class cast exception. How to resolve that issue? Correct. We got this class cast exception, but we need to resolve that issue. Correct. To resolve that issue, we should use instance of operator. Okay. So instance operator will give a return true if objects are matching. Both object A and B are matching. So we will give true, otherwise it will return false. Okay. Yes, this is only option. Otherwise, programmer should know this before doing the typecasting. They should know these are compatible or not. But what happened now? See, I see. For example, there is a very means you will get a production anywhere. Like I'm putting session in session object. I'm putting a object string. Okay, key and value pair. Okay, and the same by key. I'm retrieving some other pages or other uh, another places. Okay, so I put key as a string, okay, value as a string, okay. So I'm putting this all value correct, but problem, um, somebody has to use the same key. Other programmer, you use the same key like name, okay, but some other programmer use the same key. They put float or he put double, long as a value, correct? But both keys are same. Now it's different places you're trying to get this value. What you're expecting? You're expecting like a string, but some other user has done the wrong. Some other programmer. What he did? He put it a long value. But you, what you need? You need a string, but it's not possible. Correct? At that moment, what will come? Class cast exception. So yeah, what will get? Required string found long. That exception will get. Correct? So that is a class cast exception I will get. It happened means you use the same key but somebody has changed that key, you use the same key also, so it will come. Okay, so then that case we should use instance of operator. So how we can use, see this object instance of D, yes, then assign it, otherwise it will not assign. This is the use of the instance of. All right, no? For this, yeah. So for today, this only we have till class type conversion till. Tomorrow